Hello there channel. So today we're going to model a glass in Blender 3.6. Let's get started. So let me bring the image reference. The design of the glass itself is really amazing. So let's add a mesh circle. We're going to use 120 vertices. And I don't know the exact size, so let's go at 80. That's going to be 8 centimeters. Let's adjust this image reference, and I'm at front view, so I need this to be from the top. Okay, so the decorations on the glass are obviously super important. We're going to start easy. Let's extrude on the z-axis. So the height, 10 centimeters, is that about right? Yeah, let's go at 10 centimeters, so minus 100 here, and it is slightly conical, so let's go at, now let's go at 75% here. Now from here, let's go at the top. So here I'm going to speed up the video a little bit. I'm just extruding a couple of times to make the glass. It's very simple, should be no problem here. You can see everything on the screen. So you see, this is the easy part, the glass itself. All right, let's adjust slightly the proportion of the glass, the parallelism on the bottom of the glass. So we're going to do something here. Okay, this glass is very interesting because we have two planes of symmetry, X and Y basically. The design of this glass is, I've never seen something like that. And this is very special because almost all glasses design that you can find totally have a radial symmetry because it's much easier to design, it's much easier to do. But just look at the design before we move further. We have 1, 2 longer cuts, and this one is shorter, and then it's symmetric here to the other side. Actually, you can see, well, this is the mark of the mold, obviously. So here we know there's a symmetry here and goes to the other side. And here we can see this is the shorter cut, and you can see this one is longer, and this one is the same. Then we have like this glass very probably has been designed and manufactured here in Mexico. Very probably an agave cactus right here. And then we have stars or crosses, 4-point stars, but this one is 3 and it's rotated to follow the other angle, and that's very interesting. And there are 4 of these, 1, 2, 3, 4. These are the 2 symmetry planes. And then we have some in diagonal here, 4 cuts here, the other one there, the other one there, and the other one back there. I only have 2 pictures of the glass. And also, I don't obviously have measurements of the glass. Relaxing at the cafe, so I wasn't going to. So in this video, I'm going to show a maybe surprising method to create geometry on an object. Obviously, in this design, there are 10 stars, so the angle between the decorations is 36 degrees. But when manufacturing jewels, when working directly on the metal, there's a special problem occurring specifically when working on objects. If you want to create divisions, by example, on a ring, on a gold ring, directly on the metal. You know it's 36 degrees, but the problem is how are you going to do the markings on the ring? But also, obviously, we are here to learn methods related to the real world of making jewels, in this case making jewels by hand, and that's very specific to the problems that you can have when marking references and divisions on a complex object. And even the most simple ring is in fact a complex object when you have to mark 10 specific divisions on a ring. The gold is very slippery. Obviously, we're going to use a compass when we do that, but practically, if you've never done it, You won't believe all the practical problems that are going to arise while trying to mark 10 divisions on a simple ring. So it might seem useless. This is related to a very specific problem. So that's why in this video I'm showing a method to mark references starting from one object. In this case it's going to be a cube, because it's an interesting method to learn and that will be useful more often than you think. In real life, you'll see that working on wood, working on metal, or many other materials and more complex objects, using a starting reference point and building the entire structure of a design starting from one specific point or one specific object is always very useful. So here we are with this video. Let's proceed. Okay, so I'm going to create a cube here on the side because it's aligned here to the side. I don't know exactly the size. To distribute the decorations, we're going to make an array. Let's reset all transforms. All right, let's add some empty here. This one needs an array, obviously based on the empty. Let's start rotating, and it must end exactly at the half of that. So we're going to add mesh plane, let's make it big just to have some reference. Here let's add some thickness so we can see. So 0 offset, some very small thickness here. Okay, so now the cube, okay, so this one must end here, intersect exactly at their tips. So obviously this is too big, so we're going to find the position bit by bit. So we need to find the size of these squares to make the decorations, to make these cuts, and the angle before the curve starts at the bottom of the glass right there. Okay, I still have to adapt. So every time you adapt the size of the cube, you need to adapt the angle of the distribution there. This here needs to be exactly at the center. Let's bring the 3D cursor here. We're almost there. This is pretty nice. Okay, so here we're good, but we need to check the intersections, and the cube is too small now. Okay, so do this game and you'll find the exact position depending on the size of your cube. Okay, this is almost perfection, already a good enough precision. So now I can even make the mirror. So like I said, X and Y, we're going to base this on the glass. Okay, so here I use a very empirical process, but it's perfect for this case of geometry because the decorations, I'm going to create a Bezier curve to shrink wrap on the glass and start making all the decorations. Great, so now that I have the cubes in place showing the proportions, add curve, Bezier curve. Let's go to edit mode. Let's start roughly like this. Now let's go at 45 resolution. Let's go to shrink wrap on the glass. Now the cubes are the reference, so I need to adjust the handles and the points according to the intersections of the cubes with the glass. And now you can obviously see the very practical side of this approach. So obviously don't forget to zoom in to adjust your precision. If you don't get the precision you like, add a subdivision. Let's go with free handle type. Now here what we can do is do this, so we can see exactly the position of this point and adapt, because the angle might vary between parts, the top part, the bottom part, because of the shrink wrap on a non-planar surface. And we can see that we're getting something very accurate pretty easily. So this is one part of the decorations. Here what I'm going to do is a mirror on X and Y based on the glass, and we get this. Now I'm going to make an Alt D, a linked copy, and I'm going to make the rotation here. I need to find the angle there. Let's make another Alt D here. Let's say it's the same angle, but not necessarily. So I'm going to multiply by 2, and it's pretty good. So what I want with these lines, and that's why I'm using basic curves, I'm going to bevel them and make the cuts to get the design on the glass. Very geometrical, very precise, and we needed a method that respects the mathematical accuracy, the geometrical precision of the design on the glass. So obviously there are many ways to do this, but this is one of the most accurate and actually fast solution to this problem. Now I'm going to take these, Alt D, make the rotation to the other side. Same with these, Alt D, let's go negative. As we can see, now we have all the squares at the bottom, and we can very easily make what's next. And that's why it's very important to make a linked copy, because taking the first curve, so this makes one level. Okay, now let's take the cube, Shift D right here. Let's remove mirrors and erase. Let's rotate this minus 90 degrees right there. I'm going to put it in position here. Now the first curve, and I'm going to extrude this point, and let's adapt the position here and the handles. Okay, this one needs to be free. Make it straight, because the designs are visually straight. Okay, this completes the design of the squares around the glass, and now we just have 1 and 2 extensions, longer lines in the designs that go to the middle of the next square, the little stars, the 4-point stars, the 3-point stars, and the agave design. Okay, here's something I want to show you about the precision concerns. While making the edit, I suddenly saw that there's a discrepancy on the right side. Here at the tip, it's not centered, and that's weird. And if you look at the positions, the centers, everything seems all right. But when you have an object, don't forget that maybe the center, so let's set origin to geometry, is not centered. So here we can see that on the x-axis, this should be 0, and it's not. Okay, so it means that the original, that's this one, generating the entire array and the positionments of everything basically. Don't forget, we are jewelers. We deal with microns basically. Well, with 3D printing, microns. At the bench, we deal with centesimals. So now that the center is corrected, double check here. Now we have this. So it means that the angle of the distribution here can be slightly adjusted, and that's what geometry is. Geometry is wonderful because geometry, like everything mathematical by the way, checks itself. If something is wrong somewhere, it's going to show somewhere else, and you can always trace the path backwards until you find where that error discrepancy came from. And geometry is a bit different because most of the time you can see it, so it's visual, and then you can find practical solutions to correct it. That's what ancient cultures would do, and from that you can find theorems and very practical laws of geometry and use them in real life to design things, create houses, create jewelry, create whatever you like. That's why geometry is sacred, because it verifies itself. That's a sacred property. Right, now let's do these 2 extensions. Means that this curve needs to be a single user. So let's go to relation, make single user, object and data. Let's go to edit mode, and I'm going to extrude this roughly here first. Don't forget to save now and then. Now let me take this cube. We're going to make the rotation here. So for that, I need to use the same angle then. Here, let's make it positive. So let's place this cube here. I'm going to make it very narrow, but very high. So with this, now let's make another cube. Okay, here. Now to the curve, edit mode, and we can finish adjusting position and angle. So using references, so having a method to find the exact middle or the most accurate middle in real life or in your 3D software, that's something that one must learn. Beginners generally have a lot of problems generating good reference in space or in a piece of paper for that matter. And in jewelry, on the jewels, the jeweler always learns to create reference on pretty complex objects, because even a simple ring is not an easy object to manipulate, and drawing exact distances on rings is already pretty complicated even on the most simple ring. So jewelers train a lot. Practical means more than just mere tricks. They're really methods of dividing space in real life with compasses or any other kind of tool to mark references on objects. And in 3D, you learn to do the same. And it doesn't matter if you're not a jeweler. Any designer must learn how to create the most accurate reference points in space on simple objects and then on complex objects. So now here, the next curve, that's this one, has the same extension. So I'm going to copy the angle here. I'm going to erase this. I'm going to take this one, a linked copy, Alt D, and put the new angle. Now here, let's do the small indents up there. Let's copy this cube. Now let's take this curve here and need to erase these points. So this is correct. So these are very small cuts. Okay, so this completes these lines making the square patterns on the glass. But now obviously we must make a profile, a section for the basic curves to create the bevel geometry and make the cuts with booleans. We are going to use booleans. I'll see a few details there to make them work a bit later. Now, top view, add curve, Bezier circle. Here, let me go to individual origins, scale down. It's going to be like this. This is the design cuts section. Here we go. Now let's take a curve here. Let's go to geometry, bevel object, this. Now here we have the shrink wrap squashing the design. Here let me take all the curves. Let's make a copy. Let's join them all. Let's put the beveling here. Let's fill the caps. Now don't forget that we need to apply the shrink wrap. That's why I made a copy. We're gonna have some problems with the tilts and the endings. So the endings at the middle, and then the other one starts on the other side. We'll need cubes to cut the endings exactly at the middle sections. These type of cuts, very precise crosses, but we need half of this. So that means that we need to make the endings longer to cross the middle, because now they don't cross the middle, they're not long enough. And we need to adapt the length of the curve. So we can erase this and we can come back here to adapt curves, to adapt the endings. Let's go to edit mode. Let's extrude. Now here, let me adapt like this. They must cross the middle. We need to make the cut right there at the middle. So long enough. So again, I have all this selected. Let's make a copy. Let's join them. Let's reinstate the bevel, fill the caps. Here we are. Apply the shrink wrap. So now that the endings are long enough, we need to have a look at the orientations, the tilt of the curves, and also the straightness. So for the tilt, let's bring the glass for a second. Okay, so for the cut, something important. Let's take the profile. Let's go to edit mode. This must be bigger, but also it must come out of the glass. So let me move it slightly on the y-axis, 125. Now we need to adapt the tilt of each curve. It must be out of the glass all the time. The tilt of each section varies because of the curvature of the glass. This is good. That's not enough. Don't forget that because the curve was negative angle, the direction might need a switch. That's what I did just now. So we can get the proper placement. Maybe I need to move. Okay, the crossings must be perfect like this. Verify very easily. So check all the intersections and adapt as needed. Now the tilt of this. Check the balance on each side and readapt the position. And here these endings. The tilt might vary per section, okay? So adapt that and balance that and adapt the tilt per point if necessary. There are not that many points, so honestly, this is easy enough. All right, so here, organize yourself a bit. I made collections. These are the original Bezier curves. Then we made a copy of the beveled curves. And now a step I did already here. Don't forget that the endings are sharp, are pointy. So to do that, you can simply extrude the ending, and when making the boolean, we'll get that shape. So I did it there, but I still have to do it here. So here I'm going to do it. So it's just an extrusion. Keep the angle here straight. And like I said, these are link copies. And like I said, you need to extend the ending of all the curves. We'll have perfect sharp corners at each ending, okay? But to do that, I have to make them as meshes, because as you know, we can't make booleans on curves. But now I'm going to create a new collection, and these will be meshes. So I'm going to take all the adjusted curves, the beveled curves, make a copy, Shift D. I'm going to move them to the other collection here. I'm going to hide this also from rendering. So here I have this. Remove the mirror modifier, convert to mesh, erase the other one, make a new link copy of the mesh with the angle. Now I can put the mirrors back again, X and Y, based on the glass. If you put it before making the copy, it's a bit faster. I didn't. Okay, we have this. Now we're going to make cubes, make the cuts of the endings. So let's create a cube. Add a mesh cube. Let's make it big, because then we'll rotate this. What I'm going to do is that I'm going to center to this face the 3D cursor, and let's make the origin to the 3D cursor right there. So when we'll rotate the cutter, we'll be cutting the left or right ending as needed. So here, by example, this one needs a boolean. Now, most of the time it won't work because there's a very typical disperfection in the beveled curves converted to meshes with filled caps. The caps are always separated. So select everything, merge by distance, correct the problem. Well, first let's make the boolean up here. Okay, and now the problem is corrected. So the filled caps, the caps are never connected to the rest of the mesh. That's something we all know. If you don't know it, you'll suffer endlessly. So this one is working perfectly. Now we can see that this intersection here is perfectly sharp, like in the design of the glass, okay? So now we need to make the same for all the other curves. And by example, we need to rotate. Let's make a copy of this cube, and the other endings are here at the middle. So it means that this one, by example, needs to cut down there. We need a boolean of this before the mirror. We have this. The cut is very clean, and we need to do that for each and one of the decorations to adapt the endings so they end sharp. Here by example, boolean can be intersection sometimes. Okay, the cut here is not working because because I'm trying to make a boolean on the mirror, but the mesh is on the left. That's very funny. So what I need here is to make a copy of this cutter, and I need to rotate it. Okay, so here I'm going to put this divided by 2, and it's going to be minus. Here we are. So we already have these endings there, pretty clean. Okay, now here, what do we have? Well, I've made all the cutters for the endings, so all the endings are clear and sharp. So if you want to see all the cutters, not many, they're all cubes except 2. The endings of these elements are a bit different because they must end on the diagonal right there. Okay, so now all the cuts are done. So we need to make a copy of all these elements. I made a new collection, so let's move that to that new collection. Let's hide the originals because obviously now these cutters need to be only one mesh. But don't forget that we have linked copies. So let's go to relation, alt, make single user, object and data. Convert to mesh because they have all the booleans and all of that. Join, and we can see these are all the old cutters. This needs a remesh, let's say, obviously. The resolution, the voxel size can be pretty big. This is great. Let's make it smooth. So we have the glass here. In the first collection, we have the glass right there. Well, this glass has the bevel and the subdivision, but also all the cutters have this glass as the mirror reference, center reference. So if I work on this glass to make booleans and other modifications, it's going to be slower and not that good of an idea. So I'm not using this glass. I made a copy. What I do also is you need a remesh on the glass. And now here we're going to make the boolean of all the cutters for the decoration lines. Then we have the small stars and the agave design. It's going to be exactly the same process, but at least now we can see that the process, all the empirical process that we used, is coming to a very happy ending. So all the cutters I can hide, and here let's use a flat shading. We can see that the cuts are really clean, really precise. The boolean is working great, and yes, you need to be a bit lucky because sometimes just for a vertex, for an edge, for a face, and the entire boolean is going to fail. And that's why it's sometimes moving just very slightly a shape, and testing the boolean again will very probably solve that boolean. So here we are. So now what I'm going to do is finish all the agave design and the small stars, and then we'll start working with LuxCore to create this amazing glass in the sun angel rays render scene to recreate that magic sunlight at the cafe in the afternoon here in Mexico City. All right, so here we are with the final model of this Mexican glass. We have the 4-point stars around here, some 3-point stars here connecting to the agave design right there on the sides. And here you can see all the cutters. So these you saw in the tutorial, these I made after. They're made exactly with the same method, so that's why they're not showing in the tutorial. And here on the side, the cutters for the design on the side are just discs with a spin. Here's a mesh created using just a couple of vertices with the spin tool, and then scaled and placed at the correct angles to make the cuts on the sides, giving us this very interesting agave-like design right here on this Mexican glass. It was very interesting to make. I hope you subscribe, find my assets on Blender Market, and follow me on social media. This specific glass design is the inspiration and part of the topic on Blender Artists about spectral rendering, on the status of spectral rendering nowadays. So I will be talking about the rendering across several different render engines. Obviously, the first render I made was made in LuxScore. You already saw the images here and there, and I will keep working on the topic because obviously as jewelers we are very interested in spectral rendering for gemstones and also for metallic reflections, because you know that gold rings, by example, create very pretty metallic reflections all around, and a good photographer is always going to take advantage of that. So obviously in 3D jewelry rendering we always search for better ways to create these light rays in our render. So anyway, there's a lot of work to be done. This time the tutorial was not about a jewel, but obviously the techniques I showed today are very useful in jewelry design. So don't worry, because obviously my channel, this channel, is always going to be 3D jewelry oriented, for modeling, for rendering, and all the topics of interest surrounding 3D jewelry and rendering. This is the end of this Mexican glass modeling tutorial in Blender 3.6.